Now, on Desmos, we go there. I believe that it works. R equals 10. Oh, yeah. It will graph polar equations. Okay? So if you use a R instead of, the X's and Y's, it's going to graph polar. And we'll see in a minute how we can do this when we have thetas. So it graphs this. Also, remember, if you go over here to the wrench and change this, it'll even change it so your background is polar if you would prefer. I think I'll just leave it rectangular for right now. So we have this graph right here. This is the graph of a circle, right? And we've graphed some of these really simple equations by hand. So we should know that that one is going to be a circle because that means our radius is always 10. So if we want to change this to an equation that's in rectangular form, it's a really simple equation in polar form. It's just R equals 10. It's going to be a little bit different in rectangular form. So I would need to replace R with something so I have X's and Y's, right? Right now it's polar. I have R's and thetas, although this particular problem does not have a theta. I need to switch to something that has X's and Y's. I don't know what R equals, but I do know what R squared equals, right? So if I squared both sides of this equation, you can't always do that, but when you have a number there, you definitely can. R squared equals 100. And what does R squared equal? X squared plus Y squared. So now I could replace R squared with X squared plus Y squared. So X squared plus Y squared equals 100. And this is your answer. And typically it's left in this form. The standard form of a circle usually looks like this. These right here in our notes are not, but whenever you have these on the test, they will be multiple choice. So you will have ones to choose from there. If I go over to Desmos and I graph x to the second plus y to the second equals 100, you'll see it's the same graph because it switched from red to blue whenever I did that. So I know that these two are the same. So Desmos can really be helpful whenever you're checking these. And if it's multiple choice, it can really make it pretty easy because you just type in R equals 10, type in all your answer choices, see which ones match, right? I probably am not going to let you use Desmos on every problem, but I will have at least a section of the test that you can use Desmos for. So that is our first one. Here's our second one. This is also a really simple polar equation. Theta equals 150 degrees. All right, we've graphed these. Whenever you have theta equals something, what does that look like when we graph it? It's a straight line, right? Okay, so let's graph this in Desmos. Theta equals 150. In Desmos, there's two ways to get to theta. You can use the keyboard and then go over here to functions and maybe there's not two ways to get to theta. Thought of it. No. Okay, there are not two ways to get to theta. There's only one way to get theta, and that is just to type theta, and it turns it to a theta. So if you type theta, it, actually, let's see. No, okay. No, I don't think there's any other way to get to it. I thought there was, but there's not. So type theta and do 150. And right now, nothing's showing up. But I think it's because if you click over here on the wrench, notice right here, radians is highlighted, so it thinks it's 150 radians. We want degrees. I thought it would graph these. It'll graph r equals theta, and 2 theta, and theta squared minus r, 4r. It'll graph all of that stuff. Why won't it graph theta? Well, maybe it just hasn't. Maybe it didn't ever really. Maybe it didn't ever really do this, and I just don't know. Because you can't graph theta as a function of anything yet. Maybe they're programming that in now. Maybe. So, okay, I don't think it'll graph this one for us. But I do know that this would be a straight line, right? So if I go back up here, theta, what does it equal? Inverse tangent of y over x. So I could replace theta with inverse tangent of y over x equals 150. Now, technically at this point, you have changed it to a rectangular equation. Because there are no r's, there are no thetas. It's just x's and y's, right? So technically, this is a rectangular equation. But you don't usually see the answer choices looking like this for these problems. Because I said earlier, this is a straight line. And usually when we have a straight line, we have y equals mx plus b. So this is typically going to be solved for y when you're looking for answer choices. So if I want to solve this for y, what do I do to get rid of inverse tangent? Tangent, right? Tangent is the opposite of inverse tangent. We haven't really done that. We've usually used inverse tangent as the opposite of tangent, but it works both ways. So if you take tangent of both sides, we get y over x equals tangent of 150. And if we type that into our calculator, tangent of 150 is negative 0.577, so y over x equals negative 0.577. And then if I want to solve that for y, what would I do? Multiply both sides by x to get it out of that denominator, so y equals negative 0.577x. Now, Desmos can still help us here, even though it won't graph theta equals 150. If we graph y equals negative 0.577x, like this, and then if we change this to this graph, look what happens here. We've got the line that passes through 150. Now, you do have to know that theta equals 150 looks like that, but this still can confirm pretty much that that is correct. Okay, questions? Okay. Here are a few that we're going to look at. I'm going to give you a second to copy those down. Okay. For example 3, this is like the problem we already had. R equals 5. That's going to be a circle with a radius of 5. So I would square both sides here. And if I square both sides, I get r squared equals 25. And what can I replace r squared with? X squared plus y squared. if I wanted, I could graph both of those and it will show me that those are the same. And typically, circles are left in that form. They're not usually solved for y. Okay. Example 4 is like the one we had before. So we're going to have theta equals tangent inverse of y over x. And that equals pi over 4. But we really haven't dealt with radians very much. So for right now, I could change my calculator to radian mode if I wanted, or we can use that unit circle that I gave you. What degree has the same value as pi over 4? 45. So let's just change it to 45 degrees so we don't have to worry about changing our calculator. So for right now, I would just change all radians to degrees and then work the problem out like we did with degrees. Okay, so if we're solving this for y, the opposite of inverse tangent is tangent. So we'll have tangent of both sides. So we get y over x equals, in our calculator, we will type in tangent of 45, which is 1. And then if I want to solve that for y, I would multiply both sides by x. So y equals x. Okay. Questions? Okay. Let's look at 5. It's a little bit different. Let's graph it on Desmos. So r equals, what did I have there? 4 sine theta. Okay, so this gives me a circle, but it's a different kind of circle because the center is not 0, 0, right? The center is not the origin, or sometimes that center in polar coordinates is called the pole instead of the origin. So this one is a little bit weird, right? So if we look at this problem, on the other problems, I need r to be replaced with x squared, y squared usually, right? So I could think about squaring both sides, but if I square both sides, don't write this down because it's not right. If I square both sides here, I get r squared equals 4 sine squared theta. Not 4, sorry, it's 16. And so I could change this to x squared plus y squared, but if I look at my formulas here, I don't have anything with a sign that's been squared, especially without an r beside of it. So that's just not going to work out if we do that way. So let's do something different. There is another way to get r squared without squaring both sides. Okay, the other way is to multiply by r. If I multiply this side by r and this side by r, that gives me r squared equals 4r sine theta. And let's see why this is so much better. R squared is x squared plus y squared. Alright. And then I've got a 4. And if we look at our formulas that we had on the other, or that I had on the other slide, do you see r sine theta? What does r sine theta equal? It equals y. So we can replace r sine theta with y. So whenever we do the problem this way, we can get rid of all of the r's and the thetas, and we have an equation that will work. They can do different things with this formula. Sometimes we'll solve it for x. A lot of times we'll leave it like it is. Sometimes they'll move everything to one side. Desmos will graph it for us. So x squared plus y squared equals 4y. So x squared plus y squared equals 4y. And you'll see that those are both the same circles there. So those work out very nicely in that case. Desmos makes these problems so much easier than without, especially when they're multiple choice, because you can kind of type a lot of them in. Okay, questions? All right, now I know we've probably got a question on number 6, because I don't think you guys know about secant. Or you might. How many of you have heard about secant? A few of you. Okay? So, let's write these down somewhere down here at the bottom. This is not for this. Okay? So let's write this down. I'm going to use green so we can set it off from everything else. Okay, so there are 3 things that we use that are the opposites of secant. So, or opposite of sine, cosine, not opposite, reciprocals of sine, cosine, and tangent. So, we know that sine of theta is your opposite over hypotenuse. We know that cosine of theta is the adjacent over the hypotenuse. And we know that tangent of theta is opposite over adjacent. So I'm going to write a couple things down here that you'll need to know. So, secant, cosecant, and cotangent are the reciprocals of those. Obviously, which one do you think cotangent goes with? Probably tangent, right? So, cotangent of theta is adjacent over opposite. Okay? So, it is tangent of theta flipped. Secant and cosecant are not quite as obvious what they go with. But what I always remember for these is that secant, or in every secant, cosecant, cotangent pair, you must have a co. Obviously, cotangent goes with tangent, right? So, if I need to have a co, sine has to go with cosecant, which we abbreviate CSC. So, CSC is cosecant. And so, cosecant of theta would be the hypotenuse over the opposite. Let me write that so you can read it better. That's a CSC. And then cosine has to go with secant, because you couldn't have cosine and cosecant. That would be 2 cos. That wouldn't work out. So, secant of theta is hypotenuse over adjacent. So sine goes with cosecant, meaning cosecant is just the reciprocal of sine. We just flip sine. Cosine goes with secant, meaning if we have secant, we just flip our cosine. And tangent goes with cotangent, meaning that if we have cotangent, we just flip what we had for tangent. Now, what I really also need to know here is this. If we have reciprocals here, that means sine of theta equals 1 over cosecant of theta. If I have 1 over something, it flips that number. So like, for example, if I have 1 over 2/3, dividing fractions is easy as pie. Flip the second and multiply. I get 3 halves, right? So when we do 1 over cosecant, it flips cosecant back to sine. So that means cosine of theta is 1 over secant of theta. And tangent of theta is 1 over cotangent of theta. Here are the ones we really need to know. This also means that cosecant of theta is 1 over sine of theta. And secant of theta is 1 over cosine of theta. And cotangent of theta is 1 over tangent of theta. Because I'm doing these units a little bit out of order, we kind of got to back up a little bit and go over this here. But whenever we put this into practice, it's really fairly simple as long as you remember which function goes with which. So you remember sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Yes. I really don't have a great reason for you. Because anytime you're doing application problems, I always use sine, cosine, or tangent. I never use secant, cosecant, cotangent. So there's got to be a reason, I guess, but the only real reason I have for you in this class is because they throw this stuff in on a lot of these like problems like we're seeing here, and we have to know how to deal with them. I need to go look up like where in life you would ever need the reciprocal, because it seems like you would always just use sine, cosine, and tangent because they're easier to deal with. So it's a good question, and I don't have a good answer for you. All right, so what we'll have to use them for in this class, but this does not convince you that this is useful in life, I'm sure, is we've got r equals secant theta. But this is a problem. Let's just graph it on Desmos real quick. So r equals secant of theta. This is interesting. When we graph it, what does it look like? It's just a vertical line, right? So it seems a little bit complicated, but it looks pretty simple when we graph it. So this is what you're going to do for this. Secant, we don't know, like whenever we're talking about our formulas that we know over here, we don't have any secants or cosecants or cotangents. We only have sine and cosine, right? So what we want to do is we want to use our reciprocal identities here. And for our reciprocal identities, I know secant is 1 over cosine. All right, so r equals 2. Instead of secant, I'm going to make this 1 over cosine of theta, which I could write, if I just multiply those together, as 2 over cosine theta. Okay? Now, if we watch what happens here, if I multiply both sides by cosine theta, I get r cosine theta equals 2. R cosine theta should seem familiar to you. R cosine theta is x. So we just get x equals 2. And x equals 2 is a vertical line. Alright? And in fact, if we go back to Desmos, I will here in a second, want to make sure everybody's had time to look at this. When we go back to Desmos, we can type in x equals 2 and it's going to be the same line there. So if we go back in here and type in x equals 2, What did I? Oh, it did have a 2 with it, didn't it? Oh, good, thank you. All right. So if I graph these now, both of them are the same one. Okay. Questions? All right. Here's our next one. Okay, so this time we've got x squared plus y squared equals 25. I really already sort of did this problem in the other direction. But there's a reason I gave you this one, even though it's pretty simple, because there's something that you may miss. Okay? So x squared plus y squared, what can I replace that with? Not r, but r squared. And when I solve that for r, I square root both sides, because most of the time the answers are going to be in terms of r. So I will get r equals, but when I square root both sides, what have I got to put? A plus or minus 5. So there may be some questions that say, write this in polar form, and your answer choices might be like A, x equals 5, B, x equals negative 5, C, x equals 5, and x equals negative 5, and probably like a D, x equals 25, right? They might give you something like this, and if you do this, the correct answer choice would be C, especially if they say, like, here, only, and only, but even if they don't, C still writes the right answer choice there. So you've got to have that positive and the negative for those. You got 2 answers. And if you look at Desmos, you can see that when you graph r equals 5, and when you graph r equals negative 5, they're the same circle there. And when you graph x squared plus y squared equals 25, also same circle. Okay, questions? Alright, there's a few we can't do. Let's see which ones they are. I think it might be this one. Let me look at. No, we can do this one. It's a different one that we can't do. Alright, we can do this one. Okay, go ahead and copy this one now. Okay, so as it is right now, this is going to be pretty hard to do because I don't have like an x squared and a y squared. I could, if I wanted to at this point, replace x with r cosine theta and y with r sine theta, but that makes it kind of hard to solve as well. So I think this might be easier to deal with if I multiply it out. So x minus 3 squared, remember that's x minus 3 times x minus 3, which I can use my shortcut for if I want. Square, double, so I'll get a negative 6x and square the last. And then I'll have plus y squared equals 9. We're just multiplying out that x minus 3 squared. And then notice that here you've got an x squared and a y squared. If I that x squared and y squared together, that's my r squared, right? So let's keep those over here, x squared plus y squared. But the 6x and the 9, let's move those over to the other side. So just so they're kind of out of the way. And this is fortunate here. What happens with the 9s? They cancel. We're going to add the 6x. So we get x squared plus y squared equals 6x. And so x squared plus y squared, we can replace that with r squared. And then x, what can I replace it with? R cosine of theta. Okay? At this point, you are in polar form because you've gotten rid of all of the x's and y's. But a lot of times on these problems, they don't leave the answer like this. They may, but they may not. So in this case, I could square root both sides. But then I got like a 6 under the square root. Another thing that I can do here is divide by r. So if I divide by r, then I've only got one r left here, and I've got 6 cosine theta because the r's will cancel out over here. And this, a lot of times, is what you'll see as the answer choice. Not always, but a lot of times. And you can always check these because I think these are pretty difficult. So if we check these, if we've got x minus 3 squared plus y squared, what did it equal? 9. Okay, that gives you the circle here. And then we've got x to the, r equals 6 cosine theta. We see it's the same graph. Okay, questions? Okay, there's going to be a few of these that we can't do, but we can't do 10. I think we can do 9. Should be able to do 9. Okay, so we're going to take x equals -3 and write it in polar form. So what could I replace x with? R cosine theta. Okay, so R cosine theta, this can be your answer, but a lot of times these will be solved for R. So if I want this solved for R, what would I need to do? Not inverse cosine, because I'm not trying to get rid of the, I'm not trying to get the theta by itself. I just want to move that cosine over to the other side, so I will just divide by cosine theta. So I'll have R equals -3 over cosine theta. And it might be left like this, but we just learned that 1 over cosine theta equals secant theta, right? So this is the same as -3 times 1 over cosine theta. So more than likely you'll see -3 secant theta. So if you have a cosine in the denominator, it can sort of be moved up to the top and made secant instead. Okay, and let me see if there was another one. No. 10 we cannot do. We can't do 11 either. Okay, so your assignment is going to be page 572, and we are going to do 26 through 39, except, let me see, which ones I need to throw out. Because we cannot do them. I think we're okay. Oh no. Don't do 30. Okay, there. And do not do 37. I think we should be okay on everything else. 30 and 37 have, where I've done it out of order, we can't do those problems yet, but we'll come back and hit those once we've done that other stuff. Alright, so you got about 15 minutes. Go ahead and get started. I'm also going to go run and copy those test reviews for you so I can give those to you because a lot of